I have the pleasure this morning of introducing our first speaker, Major General the Honourable Michael Jeffery, founder and chair of Soils for Life and Australia's National Advocate for Soil Health.
Well, thank you very much, Aurora. It's very kind to introduce. Can you all hear down the back? No problem. Many of you may be wondering why an 81-year-old grey-headed retiree with not a single degree to his name is talking to such an august group of scientists and so on. And I guess simply put, it's because I'm a very worried grandfather with 10 grandchildren. And I see the next great global train smash occurring probably in the next 5 to 10 years is going to be based on soil, water and food security issues, particularly in countries like India, China, Sub-Saharan Africa and the Middle East, all of whom have great problems in those areas. And I decided when I retired as Governor-General that I would try to do something about looking at the situation in Australia and then seeing if Australia, through really getting its act together in looking at how to look after our landscapes, could not only just produce a bit more food. I mean, if we doubled food production tomorrow, we'd feed perhaps 80 million. But my theory is that if we really get our act together and export knowledge, we might help to feed 1 billion people, and that would make Australia relevant in our region and in the planet. So that's the reason, in summary, of why I've tried to do something about making a small contribution. Could I recognise the original owners of this land and pay my respects to their elders past and present, and thanks so much for inviting me to the conference and to hear me echo your concerns about the really big issue facing us, carbon, how to get it out of the atmosphere and back to where it belongs, in the soil, and a result of yesterday's deliberations also in the oceans. I found that very interesting. As Australia's National Soil Advocate and the Chair of Soils for Life, that answer is pretty obvious to me. Soil, healthy soil, regenerated soil, active working soil, has a proven capacity to draw down carbon and keep it there, yet we've literally overlooked it in the national debate about climate change. Simply put, I believe, along with a former Chief Scientist, Robin Battenham, that healthy soils have the capacity to absorb, like a sponge, at least sufficient CO2 to meet our Paris Agreement target. And accordingly, we should be pursuing with the utmost vigour a cheap, accurate, broadacre soil carbon measurement system. Such a system may well demonstrate the possibility of neutralising Australia's total annual industrial emissions of around 550 million tonnes of CO2, thus allowing a more orderly transition to renewable energy options or even nuclear. Some suggest that healthy soils may also have the capacity to catch up with the last 50 years' legacy emissions. But whatever the case, I don't think we've been focusing hard enough on the possible answer, sequestering carbon into our soils through enhancing our photosynthetic capacity. At Soils for Life, we demonstrate how to regenerate, maintain and protect strong, healthy soils through some 24 selected and performance-measured farming case studies. We intend to roll these out to 100 in the coming 2 or 3 years Australia-wide, and then I hope it'll develop its own momentum and that should become 500, 1,000, 10,000, eventually we get to a tipping point of people adopting regenerative agricultural philosophy. These 24 innovative farmers have studied their landscapes closely and worked out how to maintain permanent vegetation cover, retain more precious water in their soils where it does its job, and reduce or even in some cases eliminate the use of fossil fuel inputs, chemicals, pesticides and inorganic fertilisers. I'm not against those things at all. I think there are places for them, but surely it makes sense to reduce them where it's feasible to do so and still retain a productive and environmentally friendly and a socially friendly landscape. In so doing, they have successfully scored the healthy landscape trifecta by integrating the management of their soils, the microbial, the fungal and the nutrient function, with their water, the hydrology. Water only does its job in the soil and going back up, transpiring up through the plants and their plants. And there, of course, we should always be talking about diversity rather than monocultures. Monocultures mine the soil, diversity enriches it. With integrated regenerative landscape management, farmers store and retain large amounts of soil organic matter, which can remain in those soils for millennia. It is a fact that in our Australian agricultural landscapes, our soil carbon levels have decreased from perhaps around a healthy 4 to 5% at settlement to around 1% today. And I suggest this is one reason why we are not maximising the retention of water in the soil. And if we continue to mine those soil carbon levels, that's going to be catastrophe. I was taking it that soil carbon is not a bad general indicator of soil health. There are, of course, various established methods of sequestering carbon in our soils, such as slowing down water, conservation, tillage, managed cell grazing, forest rejuvenation, pasture cropping and crop rotation. And yet a lot of that good work can be undone by oxidation. So, like any sponge, our soils can absorb and convert CO2, but they can also have it squeezed out. I talk to you today with a real sense of urgency and a degree of frustration. According to Walter Jenner from Healthy Soils Australia, in the last 70 years, our industrial forms of agriculture have accelerated carbon oxidisation through excessive use of fire, non-organic fertilisers, biocides, irrigation and fallowing. I'm told that hot fires in Northern Australia put up as much CO2 as all our coal-fired emissions, about 150 million tonnes or there, just in hot fires alone. So surely up there we should be trying to do something with that fuel, stick it down the throats of cattle or get rid of it before it becomes a hot fire. It's not news to this audience. We must cool the surface of the planet to convert carbon oxidisation to biosequestration in order to regenerate the resilience and hydrology of the soil carbon sponge. And we can do it, but with an enormous coordinated effort at grassroots scientific and government levels. Organisations like ours and Healthy Soils Australia set out the urgent steps we have to take. Somehow we must safely and naturally cool the regional and global climate through increased photosynthetic action to offset and buffer greenhouse warming. And I often give the analogy of imagining a paddock of wheat that's just been sown into a pasture crop, where the temperature in that paddock, the soil temperature at the top is about 30 degrees. Imagine there's a farmhouse in the middle of that paddock and the temperature there is probably about 27 because the farmhouse roof is protecting from the direct sunlight of rays of the sun. There's also a big tree in this paddock with, say, 20, 25 metre canopy of big leaves. It's probably 23 degrees under that tree. It's not 23 degrees because of the shade of the tree. If it was just the shade, it'd be 27, the same as the house. It's 23 degrees because of the transpiration process with that tree in sucking up water and back into the leaves is using about 600 calories of energy, heat energy, to convert a gram of water into vapour. And it's that process of reducing heat and converting water into vapour that provides the cooling of the soil surface, provides the transpiration, and indeed helps provide a little talked about result in the local water cycles where transpiration takes place, vapour rises, and you get local showers 50 kilometres down the track, and we've lost a lot of that local rainfall. Alongside this paddock is a car park, macadam car park. The temperature there is probably 40 or 45 degrees. And the analogy there is that's a bit like our cities. They are all heat radiators. So it seems to me that if we want to cool the soil, if we want to get the water into the soil, if we want to get more carbon into the soil, we've really got to get that green stuff planted everywhere, including in our cities. We've got to secure essential water and food for more than 5 billion people who are expected to live in urban areas by the middle of the century. And I suspect a lot of that food supply is going to come from community gardens and urban gardens run rather than from traditional agriculture. We must regenerate the Earth's soil carbon sponge and its capacity to infiltrate and retain rainfall and sustain the growth and transpiration of biosystems, particularly forests across our landscapes. So what have we done to the Earth? And you probably know this better than me. We've degraded half of the planet's soils. We've turned 5 billion hectares, or 40% of the land surface, into desert and wasteland. We've polluted most of our great river systems and reduced their flows by damming. The Mekong's a good example. Headwaters are dammed up in Tibet. The Ganges flows are being reduced because of the ice shield melts in the Himalayas. Now, the impact on billions of people from the impact of those rivers is going to be serious. In India, Sub-Saharan Africa, China and the Middle East, we are steadily mining aquifers established over geological time. And we seem to be missing the boat here in understanding the seriousness of this. India's aquifers going down. China, you know, when a well went down from a farmer 20 or 30 feet 20 years ago, he's got to go down 400 feet now and the water's running out, etc., etc., etc. You can see now why I have a sense of urgency. And what we must do is to maximise photosynthesis and do it quickly by maximising the area of land under perennial green plant growth, including in our cities. Our cities should be green, the tops of roofs, etc. I'm not talking as a greenie, I'm talking straight common sense. Our Soils for Life farmers, even those technically in drought, proudly show us paddocks and plantations with full green cover, sometimes even in the drought up to the knees. Once we establish that green cover, we have to keep it there permanently, and hence the need for selective native perennials that grow green in our traditional summer months, and that should be a science thing to develop. And we have to maximise the degree to which the carbon fixed is bioconverted into stable soil carbon, rather than being oxidised back into the atmosphere through poor soil management, hot fires and so on. Our Soils for Life farmers know this and are happy to share their knowledge. Unfortunately, many of their neighbours still continue with their old industrial agricultural practices. But this drought, I can promise you, is forcing many to ask questions of themselves, including taking a look at the land management practices we promote. And I tell all farmers not to be afraid of change, to give it a go, one step at a time to transition. What we have to do is to make sure that the public, science and governments support the farmers in that transition process. And that's what I've tried to do with my soils report, advocate report to Prime Minister Turnbull and now to Prime Minister Morrison, which is on our Soils for Life website if you want to have a look at it. It's an open document. Their futures as farmers and the generations to come depend on their getting it right to preserve, maintain and protect their landscapes and their precious water and to push carbon into the sponge beneath their feet. But they can't do it on their own. And this is where you, our scientists, must rise to the challenges. So let me try and set a couple of science challenges to you. Today's session focuses on technology, and most farmers employ some technology, with drones the latest addition to the technological toolbox. But many are working in the vacuum of their own farms or their own catchments without being provided with a regional, national or global picture of how much carbon they are storing or how little. There is, to my dismay, no coordinated, clear approach to measuring carbon in our soils cheaply, accurately, quickly and broad acre. Yet soil carbon is the common indicator of soil health. Perhaps a suitable technology might include satellites working to ground sensors to detect soil carbon in real time. And I have been in touch with the head of CSIRO, the head of the Soil CRC, Megan Clark, the head of the Australian Space Agency, and various chief scientists to say, why don't you come together and get this done in 12 months. You can stick a satellite in just looking at Mars and everything else. You're telling me we can't measure soil carbon because it's too hard? I think that's rubbish. So, my challenge to you is this. As scientists, please find a way to measure soil carbon on a broad scale, cheaply, accurately and quickly. Establish where our soil carbon levels are good and vice versa. As scientists, work with other scientists to update, collate and coordinate that knowledge and provide it to non-scientists like me and agricultural ministers in a straightforward and timely manner. Provide that knowledge to government as the basis for funding, perhaps under the Emissions Reduction Fund. And most important, provide that information to farm businesses through a revised extension service system so that farmers can make good decisions about their land and animal management and qualify hopefully for carbon credits. And we really need science to help provide answers to this other great problem that very few people talk about, or seem to talk about, including scientists. Why is it that 50% of the rainfall that's falling on our landscape is going straight back up there or running off because it cannot get into the soil? And when it does run off, it runs off rapidly, taking soil with it. And there's 1 million kilometres of our streams, mostly in our farming areas, that are now incised, excised, so that they're flowing below their floodplains. And yet what do we do about water? We reallocate allocations to the Murray-Darling, or talk about whether we're going to release a bit more water from a dam to the Snowy, instead of grasping that fundamental wastage of 50% of rain, which is 25 times the quantity of water in all our dams and 5 times the quantity of water in all our rivers going up there or going every year. Surely we've got to capture that. And what about our cities? I'm told that in our cities, Canberra in a normal wet, about 370,000 litres runs off the average roof every year. Surely we should be capturing all that and recycling it. It should be part of direction to all urban planners that that's what we're going to do. We've got to get serious about water and make it a national policy with those two simple things. Get it into the ground, otherwise catch it, capture it and recycle it. Not hard, we know how to do it, but let's get it done. So our Soils for Life farmers can provide you with some of the answers to that question. They've established top cover year-round and thus slowed the movement of water from the hilltops and in their watercourses so the water better filtrates their soils. And some of you may have witnessed Australian Story on Monday night explaining this. And Peter Andrews, who in my view is the best reader of Australian landscaper and the best repairer of stream that I've seen in the country, has his other issues, but in those two areas I think he's brilliant. Some of you in witnessing that hopefully will say, gee whiz, it's not a bad idea to look at rolling out more of that catchment repair type activity. Having sufficient carbon in the soil is also very important to water retention, as you know better than I. Every gram of carbon in the soil facilitates the retention of up to 8 grams of water, but importantly vice versa. And if we're continuing to mine soil carbon as we are, surely that says straight away we're reducing our normal natural capacity to retain water in the soil. So getting carbon back is important. I've spoken about the urban runoff, and I think that's a tragedy. I have a second challenge for you, and again it has soil health at its core. Some of you would have read that the increase in childhood allergies, cancers, diabetes and obesity may be directly related to the mineral and vitamin deficiencies in our food. And those deficiencies are directly related to the mineral, carbon and vitamin deficiencies in our soils, I would suggest. I suppose it's not surprising, as wealthy consumers, we demand and get fruit and vegetables which look shiny and perfect. As any backyard vegetable grower will tell you, that's not just how they grow. But growers have to meet the demand for mass production, often off-season, and have responded with food grown undercover, treated with chemicals to make them ripen all year round, and sometimes grown without any soil at all. One expert who spent a lifetime linking agriculture to human health tells us that food has lower mineral content, lower nutrients, antioxidants and vitamins, and is likely to have chemical residues and a higher water content. I'm no scientist, but I can tell the rock melons that I ate from my father when he grew them in the backyard were much, much sweeter than the rock melons you get in the shop now. It suggested that resulting impacts on our immune system. We're told that an accumulation of chemicals in our bodies are stored in cells, causing inflammation which can become chronic disease, depending on the organ where the inflammation occurs. Our immune systems, according to some reports, are being gradually diminished, reducing the diversity of the bacteria in our gut, where it all happens, either in our own gut, and don't forget the guts of cows, animals. This is where science can and must come forward and tell us honestly and in a timely manner what is happening in respect to food nutrition. As science, you therefore need to effectively and in a completely unbiased way test the level of chemical residue in our bodies and in our children's bodies. And again, such research needs to be done in a coordinated way, write, review, test and publish widely. Indeed, is it too far-fetched to have the major chain stores advertise on their shelves meat, vegetable and food nutrition levels in much the same way as white good manufacturers have to show energy efficiency ratings? And the final point I want to make is in looking at career plans for young ag scientists. I'm appalled. I've spoken to dozens of them. Some of them burst into tears in the cabins of the four-wheel drive, because after they finish their little stint with the university on this particular project, they don't know what's got to happen. In my view, we have to re-establish the trial sites around the country sufficient to service 100,000 farmers properly. Young agricultural science should then go into those trial sites for 5 or 6 years to get a base knowledge of what's what, move perhaps to another trial site, and then, God forbid, let's post a few of them back in the departments of agriculture, where that knowledge can then be properly used instead of so many people in those departments never having been on a farm. So let's get a career structure for young ag scientists, and that shouldn't be hard to do. So could I finish totally with just a few thoughts on the PM's Drought Summit? That was the best summit I've attended, and I think Morrison came up with, was genuinely interested in supporting our farmers. And I put to him, and he agreed verbally to do it, that we need a national objective in landscape, agricultural landscape mission to restore and maintain our agricultural land, to restore and maintain the health of our agricultural landscape by integrating the management of our soil, water and plants. He also promised to do a lot of other things which we'll follow up. It was Roosevelt who said that the nation that destroys its soil destroys itself, and the history of every nation is invariably written in the way it looks after its soil. My little contribution to that is to save the planet, we must save the soil. Thank you for your attention.